Hi, my name is Vincent, and today I want to take a look at completing the square. So we have the problems, find the roots of the following equations using completing the square. And first we have x squared minus 8x plus 21 equals 6. So with completing the square, the goal at first is to isolate the x squared and the x term. So the first thing we want to do is subtract 21 from both sides of this equation. And now on the left hand side, 21 minus 21 will cancel, so we're left with x squared minus 8x equals 6 minus 21 is negative 15. So next we notice that we have a positive 1 in front of our x squared term, and the only way we can move forward and use the completing the square technique is when we have a positive 1 in front of our x squared term. And then the next step is to look at the coefficient in front of the x term, and we notice that it's a negative 8, and we need to find half of negative 8. And half of negative 8 is negative 4, so for the next line we're going to start by writing x minus 4 squared equals, and we're just going to rewrite negative 15. Now at this stage we need to think of what number we're going to write here, because we can't just make a direct substitution for x squared minus 8x by replacing it with x minus 4 squared. We have to note that when we multiply x minus 4 times x minus 4, we have x squared minus 8x, but then the last piece would be negative 4 times negative 4, which is a positive 16. So to get rid of that positive 16, we're going to subtract 16. So now from this stage here, we can move forward. We're going to add 16 to both sides of this equation. And now negative 16 plus 16 will cancel, and we have x minus 4 squared is equal to negative 15 plus 16 is a positive 1. So now to solve for x, what we want to do is we're going to take the square root of both sides. But at this stage here, we need to be really careful, because on the right hand side, we can say that the square root of 1 is 1, but the square root of x minus 4 squared is not x minus 4, it's absolute value of x minus 4. And I won't go into detail about absolute value. You could check out one of my alternate videos to dive into this concept. But this step here, all this allows you to say is x minus 4 is equal to plus or minus 1. So now what we do is we're going to solve two equations. We're solving x minus 4 equals 1, and we're solving x minus 4 equals negative 1. To solve the first equation, we're going to add 4 to both sides. And we have x equals 1 plus 4 is 5. And then to solve the second equation, we're also going to add 4 to both sides. But then we have x equals negative 1 plus 4 is positive 3. So for the first equation, our roots are x equals 5 and x equals positive 3. And you could go ahead and plug these back in to check that they are valid. So now for the next equation, we have a problem right off the bat. In front of our x squared term, we don't have a positive 1, we have a positive 2. So what we need to do before we move forward is divide everything by 2. And what this will give us, 2 divided by 2 will cancel. So in the next line we have x squared plus, and now 20 divided by 2 is 10. So we have 10x minus 12 divided by 2 is 6 equals 10 divided by 2 is 5. So now the goal once again is to isolate this x squared and this x term. So we're going to add 6 to both sides. And now negative 6 plus 6 will cancel. We have x squared plus 10x equals 5 plus 6, which is 11. So now we have our x squared and our x term alone, and we have a positive 1 in front of our x squared. So we could target the coefficient of the x term. And notice that it's a 10, so we're going to find half of 10, and half of 10 is 5. So for the next line we have x plus 5 squared, we leave ourselves a space, equals positive 11. Now if we were to multiply out x plus 5 times x plus 5, we would have x squared plus 10x, and the last piece would be 5 times 5, a positive 25. So to get rid of that extra 25, we're going to subtract 25. That way, when this expands, 25 minus 25 cancels out, bringing us right back to x squared plus 10x. So now we're going to add 25 to both sides of this equation. Let's make that a little bit neater. So we're adding 25 to both sides. So now for the next line, negative 25 plus 25 cancels, and we're left with, we have x plus 5 squared equals 11 plus 25 is 36. So now to solve for x, we're going to take the square root of both sides. And now the square root of 36 is equal to 6, and the square root of x plus 5 squared is absolute value of x plus 5. And now to move to the next stage, we just say x plus 5 equals plus or minus 6. So now to solve for x, we have to solve two equations. We're solving x plus 5 equals 6, and we're also solving x plus 5 equals negative 6. So now to solve the first equation, we're going to subtract 5 from both sides. 5 minus 5 will cancel, and we have x equals 6 minus 5 is positive 1. And then to solve the second equation, we're going to subtract 5 from both sides. And we have 5 minus 5 cancels, leaving us with x equals, and now negative 6 minus 5 is negative 11. So our roots to the second equation are x equals 1 and x equals negative 11. And once again, you could also plug these roots into the original equation to see that they do check out. Okay, well this is going to conclude this completing the square video. Thank you all for watching, and I hope that this was helpful.